Alrighty, so we're going to go ahead and move on. So today, we're going to start into our next unit here talking about transformations. And today we're actually going to talk about two because they're both pretty easy. And it's stuff you've already seen before, so should be pretty simple. So in a translation, what do?
You slide.
Okay, good. You slide. Okay?
Dude, I
It's just a
did
slide.
this.
Translation SL for slide. Okay, and we're going to talk about some more of that stuff that it's talking about there in a little bit. So on example A, does that look like a translation?
Looks like a reflection.
Okay, so the answer is no, this does not look like a translation. It does look like a reflection. That's right. Okay, on B, does this look like a translation?
Yes.
Yes. Okay, if I were to connect that point to that point, and I were to connect that point to that point, that point to that point,
Wow, it makes sense.
and that point to that point.
Makes it 3D shape.
Okay. So all of those rays that I just drew right there, are all of those the same length?
Yes.
Yes, they're the same length. Okay? Are they all going in the same direction?
Yes.
Yep, they're all parallel to each other. All right, this right here is what we call a vector. Vector. Do you remember the movie Despicable Me? That's what the little guy was. He got mad when people called him Victor because his name's not Victor, it's Vector. And so he talked about two things in that movie that a vector does. So a vector tells us two things. Number one, it tells us the distance, or that can be stated as magnitude. Talking about like force, which definitely when you get to physics. So a vector tells you how far to go, and it also tells you what direction to go. So a vector does two things, distance and direction. So as we work with this, our vectors are going to be listed in brackets like this. Okay, and I want you to notice the difference between those and this right here. These right here are like smooth curves. They're like parentheses. These are like arrowheads or like less than, greater than symbols. Okay, so in a vector, the first number is going to tell you your left-right movement. The second number is going to tell you your up-down movement. If the first number is negative, you're going left. If the first number is positive, you're going right. If the second number is negative, you're going down. If the second number is positive, you're going up. So like if I give you the vector negative 2, 8.
To the left and up.
Okay, good. So this means left 2, up 8. Left 2, up 8. Okay, so what I want you to do now is I want you to plot these 3 points, D, E, and F. Plot those on that first grid there. Plot that. D, E, and F. Make sure you label the points with D, E, and F and connect them to make the triangle. So plot those 3 points on the first grid. So you should have a triangle that looks something like that. Now what we're going to do is we're going to translate that using this vector 3, negative 6. So what's that vector 3, negative 6 going to do?
Right.
Whoa. I have the wrong tool. Right 3 and down 6. Okay? That's what that vector right there is going to do. Right 3, down 6. It's a positive 3, negative 6. Right 3, down 6. So for every point here, I'm gonna do that movement to it. I'll apply that vector to it. So for point E, 1, 2, 3 to the right, and then down 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So it's going right there. Okay, F. I'm gonna go 1, 2, 3, 1, 2, 3, 4, 5, 6, right there. And then 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay, so it should look like that. Now, what's the coordinates of D prime? Very good. 0, negative 7. What's the coordinates of E prime?
8,
8, negative 9. And then F prime? 2, negative 10. Okay? All right. Now, so this from here to here, and I can't find out how to shrink these arrows, but from here to here, I'll make my point really well though, and from here to here. Nope. Whatever. Okay. So are those 3 arrows the same length?
yes.
Yep. Are they going in the same direction?
Yes.
Yep. They're all parallel to each other. Alrighty. So now go ahead and plot these 4 points, R, S, T, and U on that second grid. All right, so it should look like that, kind of like a messed up diamond or something. Okay, so on this one, we're going to apply this vector of negative 5, negative 6. So what's that vector going to do?
Left 5 and down 6.
Good. Left 5, down 6. Left 5, down 6. So we're going to do the same thing to each point. So 1, 2, 3, 4, 5, down 1, 2, 3, 4, 5, 6. Would look like that. All right, so what's the coordinates of R prime? Negative 3, negative 1. S prime?
Negative 5,
Negative 5, negative 4. T prime?
negative 4, negative 7,
Yep. And then U prime?
negative 2, negative 5.
Negative 2, negative 5. Okay, now before we move off here, I want to think about this real quick. Okay, going from this original one to this second one here, did the shape or size change?
No.
No, it's exact same as the one before it, right? On this one, did we change the shape or size of that figure?
No.
Okay, no, we did not. So now let's turn it over. And that's what this is, a blanket transformation that does not change the shape or size. So like exactly what I just talked about. In a translation, you just slide it. It doesn't change the shape or size. This is called an isometry. I-S-O-M-E-T-R-Y. This is one of those words that will be on your test for this unit. Isometry is a transformation that does not change the shape or size of a figure. So we'll talk about rotations tomorrow. That doesn't change the shape or size. Reflections of what we're about to do right here doesn't. But next week we'll do dilations. And a dilation does change the size. So a dilation is not an isometry. Okay, so we're doing reflections on this side now. Does this look like a reflection? No. What does this look like? Translation. Just a slide straight across. Does this look like a reflection?
Yes.
Yes, it does. Okay, if I draw the line going straight down here, this is what we call the line of reflection, or line of symmetry. That'd be good. Okay, so what I want you to do is go ahead and plot these 3 points, X, Y, and Z on that first grid. Yeah, and these grids did not print very cleanly. Okay, so your triangle should look like that. Now, one thing I forgot to mention. Okay, so in a translation, we talked about it as a slide. What happens in a reflection? It is a flip, okay? You're flipping it. So on this, it's going to give us our line of reflection on all of these. So the x-axis is the one I want to reflect across. So that's this line right here that I'm going to be flipping across. Okay, so here's how I'm going to do it. Is I'm going to count how far each point is from the line of reflection. So x. How far is this point x right here from the line of reflection? It's 1. And since it's 1 below, in reflection, I'm going to flip it 1 above. Okay, along that same line. So since it's 1 below, x prime goes 1 above right there. And I think I just flew past that without explaining. So we're going to list the new point like that. We put the little mark and we say that's the prime. That way we can tell the difference between the original one and the new one. So this is the x prime. Okay, how far is y away from the line of reflection? 3. It's 3 below, so I'm going to go 3 above. 1, 2, 3 for y prime. And then how far is z from that line of reflection?
7.
It's 7, and it's 7 below, so I'm going to flip it 1, 2, 3, 4, 5, 6, 7 above for z prime. Okay, there's the new one. And you can see if you folded your paper along that red line that I drew along the x-axis, you would see how those two triangles lay exactly on top of each other. X and x prime would land on top of each other. Z and z prime would land on top of each other. Y and y prime would also. So what are the coordinates of x prime?
2, 1.
2, 1. Y prime?
Negative 4, 3.
Negative 4, 3. And then z prime?
2, 7.
1, 7.
1, 7.
Yep. Okay, next one, go and plot those 3 points, X, Y, and Z. Bless you.
Thank you.
Now on this one, we are reflecting across the line x equals 2. So where is the line x equals 2? Okay, so it is this line right here. And shade that one in on your paper. That line right there is the line x equals 2. It is a vertical line. It's everywhere where x is equal to 2. So we are reflecting across that line. Now this one's going to look a little bit weird, but it's what it is. Okay, so how far is x, point x, away from that line of reflection? It's 0, right? So how far am I going to move x prime? 0. In fact, it's just going to stay in the exact same place, right? So x and x prime share the same point since it's on the line of reflection. Okay, let's look up here at z. How far is z away from the line of reflection? Well, it's just 1, right? Z is just 1, and it's 1 to the right. So to do the reflection, I'm going to flip it 1 to the left along that same line. So the z prime goes right there. Now, how far is y away from that line of reflection? It's 6, and it's 6 to the left. So to do the reflection, I'm going to flip it 6 to the right. So 1, 2, 3, 4, 5, 6 to the right. And there's my y prime. All right, so now I'm going to connect these points. And it looks kind of weird, but you can see how, you can see, bless you, how it looks symmetric around that line x equals 2. I like to think about like it's kind of like maybe spinning, you know, like it's on a pole and it's just spinning around. You can see how, as you spin it on that, how it lands back on top of itself there. Okay, so what are the coordinates of x prime? Now, be careful on this because a lot of people do this. This is still the origin right here. This is still the origin. That's still 0, 0. A lot of times people see that x equals 2 and they start thinking of that as the y-axis. No. So where is the x prime at? 2, negative 1. Where's the y prime at? 8, negative 3. And then where's the z prime? At 1, 2. Yeah, again, be careful. That blue line is not the y-axis. The blue line is x equals 2. So z prime is over 1 up 2. So it's at 1, 2. Okay, I'm going to skip that third one. Let's go ahead and look at the last one here. So plot those 3 points real quick, R, S, and T. Now on this one, we are reflecting across the line y equals x, which y equals x is this diagonal line like this. Okay, it's everywhere where y is equal to x. So at the point 1, 1, 2, 2, 3, 3, 4, 4, and everything in between there. 1.5, 1.5. What's this diagonal line right here? So I'm going to take this and flip it over, and it's going to put it somewhere right up in this area right here. Now, we could count it, but it's a little bit difficult, but there is a rule that makes this pretty easy. So when you reflect over the line y equals x, all you do is you switch the x and y value of each coordinate. All you do is you switch the x and y. So what we're going to do is we're actually going to list r prime, s prime, t prime first, then we'll go back and plot them. So for r, to reflect it over the line y equals x, I just switch those. It becomes negative 6, 4. So where's s prime going to be at? At 0, 5. And where's t prime going to be at? Negative 1, 2. Okay, so let's plot those new points, and you'll see that puts us where we need to be. 5, 6, 1, 2, 3, 4. 0, 1, 2, 3, 4, 5 is t prime. Or no, it's s prime. And then negative 1, 2 is t prime. Okay, so again, you can see if you folded it along that line that I drew, that big bold line, if I folded the paper along that line, that those two would match each other up. Okay, real quick before you get grouped up, I want to show you what I want on this real quick. Okay, so look at the side that says translation. So on the first one, just 4 units down. So everything just down 1, 2, 3, 4. The other one's right here, 1, 2, 3, 4. And so you get this triangle right here like this. So I want you to do the translation, like move it, but what I also want you to put on here that it doesn't say anything about is I want you to write the vector of what it would be. So if it's just 4 units down, what would the vector be?
Negative, or 0, negative.
Be 0, negative 4. There's no left-right movement, just down 4 units, so that's what that would be. Okay, number 2 says 6 units up and 5 units left. Now be careful, because on here, they kind of switch back and forth. It says 6 units up, then 5 units left. Good, so it'd be negative 5, 6. See how they did the up first and then the left next. But in our vector, we always put left, right first and up, down in the second slot. Okay, so on the third one, you can see how they flip back to 5 units right, 3 units down. So what would that vector be? 5, negative 3. So make sure you write the vector and then also draw where the second triangle would be on each of those. Okay, on the back, on the reflection. So number 1 says reflect across the line x equals 4, which is this line right here. Okay, so I'm just going to quickly count. A is 2 away, so I'm going to go 2 to the other side. And so A prime is right there. B would be 5. It's going to be right there. C is 1, 2, 3, 4. 1, 2, 3, 4. This is 3. This is 5. And this is 2. So it's like this. And you can see how that got flipped over that line of reflection there. Okay, number 2 is across the line y equals x. Just use the rule I just gave to you on that. Number 3 says across y equals negative 1. That's this line. And number 4 says across x equals negative 3. That's this line.